Okay, this is lesson 26. We're talking about continuing on solving equations. We started with one-step equations, just real easy single-step equations, and last Thursday we did two-step equations. So today we're doing multi-step. It could be 3 or more steps per problem. Okay, it could be any amount of steps per problem. It's just however many you need to get the variable by itself. Okay, so the concept of what we're talking about today, think about like a farmer, okay, who has goats. Okay, what do goats do? Meh. Or is that sheep?
That's a sheep.
That's a goat, right?
No, goats, haven't you heard the yellow
Yeah.
goat?
I think I made a pretty good goat impression. So,
Or some go boo.
anyways, let's say we had a farmer with two sides of his ranch. Okay, and he had goats everywhere. And goats, you know, they eat anything and everything. Let's say he had 3 goats on one side, a couple of goats on the other side, right? And then he had a bunch of hay bales everywhere. Let's say he had a couple of hay bales here, 5 hay bales here, 3 there, 10 there, and 2 there, right? We could say that the left-hand side, well, before that, rewind just a tad. Okay. The farmer wants to make sure all the goats get the same amount of food, right? What happens if goats just keep eating? Will they stop?
Turn fat.
No, they're going to turn fat. What happens if the other goats don't get the food that the other goats eat?
Go skinny.
They go skinny and they'll be unhealthy. Maybe they'll die. Okay. Everything doesn't have to die. Okay, so as the farmer, we want to make sure we organize everything appropriately so that, you know, the goats get the same amount of food all the time. So you could say that this is like an equation. On one side I have 2 goats and 5 bales of hay, and on the other side I have 3 goats and 15 bales of hay, right? So my goal as a farmer, check this out, is I want to move all my goats to one side, and I want to move all my hay bales to the other side. So I'm going to move all my goats one side, hay bales to the other side, and then I'm going to use this, what we've been learning, to divide my food. Does that make sense? Okay, cool. So here are the steps for today. If you're on the video, you should pause. Okay, watch me do numbers 1 and 2. Okay. Number 1, we got an equal sign here. I'm going to use the fence still just for the sake of students who aren't getting it. Okay. I got -8 is equal to -6 minus 5x plus 6x. I'm noticing all my x's are not together, so I want to combine like terms. Another way I could write -5x plus 6x, I could substitute these 2 terms with one term. So I think, what's -5x plus 6x? It is 1x. Okay? And I'm going to bring the rest of the problem down, and I'm going to ask myself, what property did I use? Well, I substituted, right? I substituted -5x plus 5x, or -5x plus 6x with 1x. Okay, then I'm going to just work out the problem like I did last week. I'm going to ask myself, are there any subtraction signs by the x? Yeah, there's a -6, so I'm going to add 6 to both sides. I use the addition property. -8 plus 6 is -2, and then we have x here. Now, this could be the answer, but I like having my x, or my variable, be first in my answer. So I'm going to switch sides here. Just like my face is symmetrical, my problem is symmetrical on the line of symmetry of my answer, like my fence. So I'm just going to switch sides. We're going to put x on one side, and then we're going to put 2 on the other side with a negative sign. It's a -2. And there's a property that we use. It's called the symmetric property. Okay? And that's it. That's how we do number 1. Okay? Any questions on number 1? Okay, number 2. Okay, same thing. We got 2n minus 4n is equal to -12. I want to combine like terms. So we're going to take 2n minus 4n. We're going to combine like terms. So we're going to substitute 2n minus 4n is -2n. And that was a substitution property. So -2n is equal to -12. Oh, well, there's the answer. And then I divided both sides by -2. Use the division property of equality. And then we got n is equal to -12 divided by -2, which is +6. Okay? Does that make sense? Questions on numbers 1 or 2? Yeah.
So I'm going to use the symmetrical if it's flipped or something?
Yeah, we always want to have the variable first, so it says x is equal to something or n is equal to something. Does that make sense? Questions? Any other questions? All right, so what I'd like you to do is turn to your neighbor. Let's have one solid twos about number 1. Working on number 3 now. We got 2x minus 4 plus 6x is equal to 12. Okay, turn to your neighbor, tell him what you would do first on number 3. What would you do first on number 3? Okay, what would you do first on number 3? Someone, what would you do first? What's that?
Combine like terms.
Combine like terms. Okay, so what's 2x and 6x equal to? Good. What property is that when you combine like terms?
Substitution.
Good. Substitution property. Okay. Now the rest of the problem, do you think you could do this by yourself? Yeah, go. Give you 45 seconds. This one, add 4 to both sides. You got 8x is equal to 16 divides both sides by 8, and we get x is equal to 2. Okay? Good. Number 4, by yourself, all the way through. Number 4, go. Number 4, k is equal to negative 4, right? Combine like terms. When you combine like terms, what property do we use when we combine like terms? How did I get negative 5 here? What property? Substitution property. And then when I add 5 to both sides, that's called the addition property of equality. And then when I divide both sides by 2, I get the division property of equality. Good. Number 5. Okay, number 5. Raise your hand if you were confused by some of these problems yesterday on your homework. Number 5. Okay, so we have, let me walk through this one first before we start working it out, okay? I'm not releasing you, so just write it down on your boards. We're going to do this together. Take a moment to write this down on your boards. Okay, so on number 5, we got 20 minus 4k is equal to negative 8 times k minus 5. Okay, so we have k's on both sides of the equation. Okay, so I'm going to draw my fence there so you can see. There's k's, negative 4k's on this side, and then we got k's here, but they're in parentheses. When we have a k or variables on one side, let's just distribute it. So we're going to use a distributive property. We're going to multiply negative 8 times k, which is negative 8k. Negative 8 times negative 5 is positive 40. Oh boy. Okay, and then we're going to bring the rest of the problem down. Okay, what property did I just use again?
Substitution.
No, what property did I just use? Distributive property, good. Now, are my k's on one side of the fence? No, so I want to move all my k's to one side. So I like moving all my k's to the left-hand side because that's the way we're going to end off anyways. So I have negative 8k's on one side. I want to move these negative 8k's to the opposite side. So I ask myself, what's the opposite of negative 8k? Add 8k, right? What's the opposite of subtracting 8k? Add 8k. So we're going to add 8k on both sides. So we're using the addition property. 20. What's negative 4k plus 8k? What's negative 4k plus 8k?
4k.
Positive or negative 4k? Positive 4k, which is equal to 40 here, right? Okay, can you guys and girls work the rest of the problem out for me? Okay, go. We're going to subtract 20 on both sides using the subtraction property of equality, and then we're going to divide both sides by 4. So we got k is equal to 5. Okay, k is equal to 5. Any questions on number 5? Okay, good. Last one. Let's see you do number 6 by yourself now. Number 6 all the way through. So on this one, you should have distributed the 4 first using a distributive property, and then we're going to use the substitution property to bring the piece together on the right. Now on this step, what do you notice here, just before we even move on? What do you notice on both sides? They're both the same, right? It's like saying that each side of my of my seesaw is perfectly the same. Identical twins, exact same weight. Okay, so whatever I do on one side is not going to affect the other side, right? If we have identical twins on one side, what if I had 1,000,000 pounds to one side of the seesaw and 1,000,000 pounds to the other side? Is that going to affect the balance of the seesaw? No. Does it matter what number I add to the seesaw or how much weight will it affect the seesaw? No. That means I can use any number here. So the answer here is going to be P is equal to all real numbers, or another way you could put it is you could say P is equal to infinite solutions. Infinite solutions. Does that make sense? Raise your hand if you want me to re-explain it. Okay, great. That concludes the lesson. Turn to your neighbor, please discuss these questions. I'm going to call on you in about a minute. Ready? Go.